Say we have an unknown device, or it might be an amplifier, it might be an op-amp, it might be a transistor, and we want to characterize it. One of the most important parameters that we're going to be interested in is what is the input impedance of that device. In this model here, I've drawn input impedance as a specific component. It's important to realize this is a hypothetical component, and the input impedance may have a number of components within the device that contribute to it, but we can model these as a single element. The first thing to do to find this single hypothetical Zin component is to connect our device to power and then to connect it to some test signal Vs with an explicit series resistance between Vs and our device under test. And before we do any, before we connect the series resistance Rs to our circuit, we're going to measure it very carefully with a multimeter so that we know the value of the resistance of Rs very well. Knowing Rs, we're then going to measure voltages, and we're going to measure the voltage here. That will give us Vs. We're also going to measure the voltage here. This will give us the voltage going into our component, Vi. And the reason that we measure these voltages is so that we can find the current flowing through Rs, which will also be the current that flows through Zi. We can write an expression for that current. It is going to be the voltage drop across Rs, which is equal to Vs minus Vi, divided by Rs. Alternatively, we could say that the current I is going to be Vi minus 0 volts, because we're connected to ground here, which is 0 volts, divided by Zi. Now, these equations for I are equivalent. One of them has Zi in it, so we can rearrange to make Zi the subject. Zi is going to be Vs minus Vi over Vi multiplied by Rs. A couple of things to be aware of. We want to choose the size of Rs to be approximately similar, well, within an order of magnitude of the impedance that we expect for Zi. Doing that will ensure that Vs and Vi aren't too close to each other and aren't too close to 0. And if we do that properly, we should get a nice accurate calculation of what the input impedance for our unknown device is.